Hello everyone, I am back again and we will be discussing in this lecture errors in GIS and key elements of maps. Though these are two different topics, but I have deliberately kept in one lecture because these are the topics which are least discussed in literature or in GIS domain. People do not want to discuss much about the errors. Whereas this is very important that you know that error propagates in GIS, and therefore the basic purpose of GIS not to introduce the errors, to keep errors at the minimum, and therefore we need to look into the sources of errors and how we can manage the errors so that we keep them at the minimum. And second, a small topic which I am going to also discuss in this lecture, the key elements of maps. Whenever we prepare maps, we do not look towards the cartography or the elements which need to be there in almost each and every map, depending on your requirements. So these key elements we will be also discussing, their intricacies, what kind of these elements are, and how they can be placed, what are the importances of these elements and every. So all these details we will go. So let us start first with the errors in GIS. Before that, we need to understand two terms. Sometimes we use them interchangeably, sometimes we use them synonymously, but these are two different terms. The first term is precision and second term is accuracy. Accuracy is rather easily understandable, so I will touch that one first. Accuracy is a statistical term or concept which states that the likelihood of probability that a particular set of measurements are within certain range of true values. And whereas the precision is a statement of smallest unit of measurement to which data can be recorded. So accuracy depends on user, how accurately he measures using a certain tool or technique, whereas precision is dependent on an instrument. I will give you example. Like you might be having a 1 foot scale. On one side you are having inches, another side you are having centimeters. So if you see against 1 inch there are 10 divisions are there, and against the corresponding 1 inch you would find there are 2.5 centimeters. That means you are having 25 millimeters or 25 divisions. So if I ask a question which scale is more precise, obviously your answer would be the centimeter scale, because it depends on the instrument. You can more precisely measure a length using the millimeter or centimeter scale rather than inch scale, because in inch scale the divisions are only 10. For the same distance, that is 2.5 centimeter, you are having 25 divisions. So this is what the precision is. Similarly, in case of like screen resolutions or camera resolutions, higher the spatial resolution, more the precision you are having. And in case of digitization, in case of heads up digitization, we need to go for higher resolution screens to reach to that precision. Whereas accuracy depends on the user, how precisely he measures the things. And as you know, in simple physics experiments, we were asked to measure certain things or do the experiment 5 times and then take the average of that one. So this is what is that the likelihood of probability that a particular set of measurements, maybe 5 measurements, are within the certain range of true values. So that will give you that how much accurately, but unfortunately things people have been using synonymously or interchangeably, which is not correct. Now certain things can be controlled, like precision we cannot improve. Once a data has been recorded, precision cannot be improved, but accuracy probably can be improved, or the errors can be kept at minimum. So maps and other data sets which are used in GIS are obtained by measurements and therefore inevitably contain errors, no matter how small. If you take say a survey map, say topographic map, those maps too are having some errors. Some organizations will declare that what kind of horizontal and vertical errors are there, some organizations do not. But if they mention that generally in a 50,000 scale topographic maps, the horizontal errors are somewhere around 30 meter. So that the object which you are seeing may be within a 30, in a reality they may be within the 30 meter radius. So that means the plus minus 30 meter. Now as I have mentioned that GIS users must understand the two types of basically errors, the inherent errors and operational errors and their propagation. Inherent errors sometimes we cannot do much. If data we have bought or downloaded or purchased from somewhere or is given to us by some organization, we assume that it is very accurate, but may not be, it might be having some errors. So the better it is to have that knowledge that what kind of errors it is having. So those are, we will put them in inherent errors. Operational errors are committed by the GIS users. So those things should be kept at minimum, because you know error propagates in GIS. And this is what I have also in the beginning mentioned, that errors in GIS are perhaps the one of the least understood aspect. And that is why in literature you would, in many books on GIS, will not have even a chapter on errors in GIS. So that is the least understood and least discussed part of GIS. Always it is not possible to remove errors, because there are inherent errors. Everything cannot be done by a single GIS users or a one organization. We have to get the data from some organization, some sources. So it is not possible to remove errors. However, attempt should be to manage and kept them to an acceptable minimum, so that we should manage in such a way that errors do not propagate, one, and if they have entered in our analysis or in system or in data, we should keep them at the minimum. But the information or knowledge about inherent errors and operational errors must be there with the GIS experts, so that you can explain to the people that this much of confidence you are having in your analysis. Let us look what are the sources of errors in GIS. The first one is the errors in the source data. There might be geometrical or positional errors. While doing the survey, say a topographic survey, there might be errors in positions, and classification errors of remote sensing data. Sometimes you get a land use map prepared by some organization. If they have done the wrong classification, because that land use map have been prepared using satellite data, and if a wrong classification has been performed, properly it has not been checked, or ground verifications have not happened, and that data if you are using, that is, we will put that error in the source data. The field data sampling or ground control points we have discussed in georeferencing part. So if georeferencing is wrong, that means the positional accuracy issue, and therefore these are the inherent errors. Maybe the sampling while the data is collected in the field may not be, the coordinates might not have been recorded properly, or the measurements which you have done. Suppose somebody is measuring water level in a duck well. Now if measurements have not been done properly, then that error will remain in the data forever. So these are the errors one has to take care. Second source of error is the errors occurring during data input. Now when if digitization is done or attributes are being typed, at that time such errors can come. And for example, digitizing errors, operator mistakes, limited precision of digitizer. Some earlier or then heads up digitization, if screen resolution is poor, you will bring errors in the data. So one has to take care about that. Errors in attribute data entry, while typing the attributes in a table, if a wrong value has been typed or wrong name has been typed, that error will remain there, and we have to find out why. If we anytime we detect that error, the best practice is correct it immediately, then go to the next step. and errors due to wrong band identification of remote sensing data. This is also sometimes happens because for this number of bands are increasing, maybe having say 7 bands or 20 bands or 30 bands of a remote sensing sensor. You are choosing a band, might be wrong, and when you make the color composites of these bands, that might be wrong, and then if you use such color composites for classification purposes, then once the wrong combinations have been chosen, your classification is bound to be wrong and would have errors. So this kind of errors can also occur. Now third type of errors, sometimes this can also occur, the errors in the data storage due to limited precision. This is one of the mistakes which people commit generally when they are bringing the data, attribute data spatially. So you have to declare the properties of your field in your database, and that property, that how much precision the data will have will require when data comes, say 2 places after decimal or 4 places after decimal. And if you have not kept, and you have kept just a simple without any decimal places after decimal, then you are truncating your data, and therefore the precision of your data will get reduced. So that is why, due to limited precision with which coordinates and numerical data are stored, and format conversion. When we discussed about raster to vector conversion or vice versa, at that time I also mentioned that these conversions, transformations are not truly transparent. What does it mean here is that when you convert from one model to another, one format to another, you are introducing some errors. So one should know that the data which he is going to use or using in his analysis, how it has come, whether it has come from raster to vector conversion or vice versa, and what kind of errors it has introduced. So these conversions will always bring some errors in the data. Those errors part, while converting, we have also discussed in detail when we were discussing these conversions of the vector to raster and vice versa. Now fourth in this category of errors, the errors in data analysis and manipulation, that may be propagation of errors due to during map overlay, that is one source. Errors due to incorrect use of logic or equation. While discussing in the GIS analysis part, especially in overlay and putting the syntax or the commands for analysis, if you I also mentioned that if you wrongly use the brackets, the position of brackets have to be very carefully done, otherwise the wrong analysis will come. If you have not detected at that time, then that error will come in your final outputs, and your results will have very less level of confidence. So every time I also mentioned that once you are having a complicated analysis or compound logic or compound syntax, it is better to do it in say 4 pieces instead of just one go, because after one step of calculation or analysis, you can check the errors. So you are sure that at least 1/4 part I have checked, it is fine, then next part, rather than bringing a complicated equation or syntax and going analysis in one go. Errors arising from interpolations, because in interpolation we use the point data generally, and there might be because different interpolation techniques will do it interpolation differently, and they might bring errors. So once you have done the interpolation, there itself that would be the right time to check for errors, and if you are satisfied, then only you use that data for the later analysis. If errors are found, detected, immediately those should be corrected. Appropriate interpolation technique would always help. So once I also discussed this part when we were discussing that which interpolation technique would be suitable for my data set, that can also be identified after doing certain iterations and analysis on your data using different interpolation techniques. So, errors in interpolation, maybe due to extrapolation also errors can come. And finally, in this category is the errors in data output and application. For example, the cartographic errors, due to which cartographic part which that the key elements of the map we will discuss in this lecture little later. So, cartographic errors due to limitations of output devices. Here means that the resolution of your output device is not as good as you should have been. So, data may be of high resolution, but output devices are having poor resolution. You are losing the quality of data, might be bringing errors. Similarly, I also discuss that when you are using a say TIFF format data and a raster or say an image, you convert it to the JPEG, you are introducing some errors, you are deteriorating the quality of your image. So, these things have to be remembered for so that errors remain at their minimum level. Incorrect or inappropriate application of GIS products. See, GIS is not a universal tool, and probably no universal tool exists in the world. Remote sensing is also not a universal technique. So, there are limitations of GIS which we will also discuss. So, these limitations basically tells us that everywhere the GIS cannot be employed. For if understanding is not there, tools are not there, algorithms are not there, unnecessary utilizing GIS for that particular application will bring you wrong results and wrong name for the GIS. Now, the next part of this lecture is key elements of a map. This is generally what happens, that people after analysis they have done it and they bring a map which might not be having all the key elements, and then people will start asking question that in which direction is the north, what is the scale, which area, and so on and so forth, what is the legend, what is the unit of your legend, and so on and so forth. So, all these things one should keep in mind while preparing these layouts or map final outputs, because you might have done very good analysis, your data might be highly reliable, everything you have spent so much time and energy and resources to create that kind of analysis, but if you do not make nice output or maps, you have missed everything almost. So, it is always to think in this direction, that what are the key elements should be there in my output map, so that whenever it is presented to anybody, either through PPT slides or printouts or any way, it should be very complete and accurate as well. So, regardless of the whatever the style one is following, which is cartographic style, content, most maps should have the following common elements, and which we put them as golden rules of cartography. The title, each map should always have a title. If somebody is going for a publication in a scientific journal, still you can have title, but generally you carry with a caption. So, because if a map is do not carry, map does not have the title, then what would happen? Then people will ask, what is this map? What you are trying to show? So, title must be there. Then, and the size of this the characters in title should be relatively quite large, and it should be obvious that okay, this is, so first thing is whichever the thing is which is large, the people will notice first, and therefore one should choose the large font here. And then you should tell that, for example, land use map of the study area. Once you have said land use map, then of which year. So, title should also be sufficient, should have the sufficient information, should be very brief as well as precise. And if you can put a title in a box, that would look also nice. Then scale. Scale is very important, and that has to be there, and do not put scale in ratios. Several softwares will support both kind of scales, but if you put a scale say 1:50,000 and somebody changes the size of that map, now that scale will not change, but what scale, the best thing is put a scale bar, and you must mention the units as well along with the scale bar. So whenever a size is changed or it is projected, the same scale bar accordingly will also be get enlarged or reduced, and therefore there will not be any confusion about the scale. So scale is another very important key element of a map. And as I have already said that the unit must also be, if it is representing a distance, they may be in kilometer, meters or so on and so forth. Now orientation, this is depending on the requirements, whether maybe as per requirement. If it is a normal and normally it has been laid out or presented, then north should be mentioned upward. If it has been rotated, then accordingly the north direction should be shown. Generally people avoid putting all these symbols, but in a good software these tools are already available. While going for layout, these tools are available, only thing you have to pull and put it at appropriate location about the north direction, which is very important. If you have rotated the map, take care that since you have rotated the map in order to fit it in a landscape, and therefore you must see that your north is also rotated accordingly. The fourth one is the border or neat line. That also defines that this is the area of interest. This is what I have worked. If you do not have any border or neat line, then it looks that it is incomplete kind of thing. So that is another important thing one should have along your map outputs. And then the fifth one here is the legend. This is very important. Suppose you are having a digital elevation model as a map output. Now if you do not have the legend, how a person would know what are the range of elevations present within your digital elevation model? So once say you are having a digital elevation model, suppose it is ranging between 0 to 1000 meter. So at the bottom, whatever the colors which are representing 0, you should show that with 0 and 1000 and then unit. Unit of measurements must always be also there along with the legend. So this one has to remember that this legend has to be there. It depends on what kind of maps you are. One another thing is that legend should not be very complicated, very simple. If the high precision is not required for the range of values, do not keep up to 3 places or 2 places. For example, pH value. Generally pH will be measured only for 1 place of decimal, but because of your wrong precision declaration during your data, you might have 2 zeros or 3 zeros after 1 place of decimal. Now why it does not have any meaning? So because of wrong precision declaration, you will have that thing and it will unnecessarily clutter your legend. So legend should be very precise, very brief and full of with complete information. Now map credits, this is another important thing. If you have got map from somewhere or use somebody's map, modified it accordingly, if you have prepared by yourself, then that thing is not required. It is understood that it is your generation. But if I have used the map, say Geological Survey of India, so I will write somewhere in the map that the source is Geological Survey of India or some publications. If I have used their maps, modified it, updated it, and then I am using or presenting, then I will write after that. So the map credits must also be given. That is also the source of data and date of data. If it is remote sensing data, one must mention that what was the date of the remote sensing data, so that it brings the completeness in your map presentation. And some other things can also come, like who has prepared, what was the date of preparation, what was the date of the data, date of the map, and also the projection. If you are following some different projection which is not normal, then you must also mention that this is in the UTM projection or polyconic projection, Mercator projection, depending what thing, so that it is having a complete information. Now locator map, location map is also sometimes given, mainly in the publications and other places, that which say map of India is there. Now in a small study area which you have bugged, say part of Uttarakhand. So in somewhere in your bigger map, you should have a inset where map of India is shown, just boundary or maybe boundary of different states of India, and within that your study area, say within that Uttarakhand, maybe a square, rectangular, circular or whatever area. So this inset will give the immediate information that which is the where exactly the study area is located. So this inset map is also very much required. When I was discussing generalization, here now that generalization will be applicable, because when then that map of India, let's say with this state boundaries, when you will present in a small form, that means going for a very small scale, you should go, if you are having for large scale or digitize at a very high resolution, now you are using for a small scale. So first you go for generalization and reduce the small details all along the boundary or these polygons, and then you present. Otherwise what would happen, that map will not look good, that inset map or locator map. So that is another very important thing to remember. And now this overall this effective graphic design, if you are sending for publications, color is not a limitation, then you should choose appropriate colors. Do not make too many. If too many colors are not required, don't bring too many colors. But if colors are not restricted, then definitely you should use some colors to highlight certain things of your output map. So that depends on individual style and other things. Many standard layouts are always available with standard softwares which can also be used to prepare such maps. The other thing is that if you are presenting in a black and white and you are using some hatching and other things, that is also that care must also be taken, because you might be printing at say A0 size. Later on this map in publication will come in A4 size. When it is reduced, this hatching or patterns should not get disturbed. So choose that pattern which will not get disturbed much once a map is reduced or enlarged. So that thing must be also kept in mind. Now the purpose, because overall you have to remember for what purpose you have prepared that map, to whom this map is going to be used. If it is by a layman or a tourist, then you should not have too much information on the map. But if it is for the scientific use, then for that particular purpose it should emphasize, remaining things may remain in the background. So the purpose should also be very clear, should be kept very clearly in your mind. And this brings to end of this presentation. Thank you very much.